Right, we'll move on to the next session, please. So our next speaker for our Lost in Translation talk, so this is about thinking about what happens when you've got the funding and how do you make sure things progress properly. So the first speaker is Susan Bright. She did her initial studies in Cambridge in immunology and then has worked across a range of companies, including SmithKline and Celltech, Lonza, lots of large, big names in this space, and is now working as a semi-retired independent consultant, supporting people like us trying to do translational research.
Thank you.
Thank you.
Thank you. I'm going to start off with a disclaimer. Parts of what I'm going to say are based on facts, but there's a large amount of fictionalization. So please don't sue me. Yes, I've looked at translation from all sides, from the end user, the patient, all the way to the inventor. And I've seen lots of mistakes. I've tried to get a common reason why these happen. But let me start off with the first mistake I was a personal witness to. So this is Cesar Milstein, at the MRC, Nobel Prize winner, inventor of, he didn't do it on his own, co-discoverer of monoclonal antibodies, which then went on to be multi-billion fortune. As you may have heard, he went to his tech transfer office just before the Nature paper was due to come out and said, should we patent this? The office said, no money to be made in this. Nature paper came out, and in those days, I don't know who was earlier saying about Nature, but the paper is very short and you're not supposed to do any speculation. So all he could say was a one-liner saying this may be of some use, this invention. That afternoon, several large US companies had already filed patents in use in diagnostics, etc., etc., etc. After that, the UK closed the stable door. We created the new company of Celltech, upgraded tech transfer offices, but it was too late for this technology. But there is more to this story, obviously, than the simple thing of tech transfer office wrong, scientists right. There was a discussion, the paper had already been accepted, and there should have been an earlier discussion, and he should have explained more carefully to this tech transfer office, who was trying to deal with everything in Cambridge from soup to nuts, what this technology meant, what it could do for patients. So it was a great breakdown in communication between those two stakeholders. Which leads me to my next person. I realise I've got a lot of elderly men on my... It's my demographic, I'm afraid. Yeah, they used to be good looking. But Roger Fisher, I was really privileged to attend a workshop he ran in Harvard Law School, called Getting to Yes. And he wrote, and the book is still he's not alive, but the book is still widely used amongst business development courses, and it's about negotiation. He was very highly involved in the Middle East and had a lot of success there. But I came away with three messages. First of all, you want to go for end up with a win-win with the person, with the organisation that you're negotiating with, the person you want to walk away from your negotiation with an agreement that you're both comfortable with. Number two, in order to do that, you've got to look at life from their point of view. Step into their shoes, look at, me from their point of view, and see, what do they want, what do I want? And number three, if it's not going to work, if there's no joining of minds, then walk away. Best alternative to a negotiated agreement is to say, no, you've got to have your no. Now, why do I bring this up in this context? Because I think the translational pathway is full of establishing relationships all the way along the line. And if you don't get those relationships right, and I'm going to give you some examples, then the project will fail. And these are the pitfalls I'm going to talk about. Not scientific pitfalls, but relationship pitfalls. And they do happen, and they happen a lot. These are just some examples. The inventor with their own lab, the inventor with the university tech transfer office, the two of you together with a potential funder, working with the regulators and the developers, working with a commercial partner, a development partner, working with a contract manufacturer, a contract research organisation, and working with the end user. And as I say, I've seen all of these, and I've seen them go horribly wrong. Okay. I just realised I got all these. This is not a member of my family, but it could be. If you see my husband later. No, so this is an example. In this particular case, I was the tech transfer officer, and the scientists had come to me and said, I've got this new technology, let's patent it. So I did. No, not me personally, we did. The patents were filed, and then I happened to be at a partnering meeting, and a guy there, I realised there was a company there that was working in the same field, so I invited them to come to our organisation to have a meeting with the scientists. Filed a patent, need a partner. That was my thinking. No, so he turns up like this, more or less, scruffy old clothes, and spent a lot of his time not engaging back to the audience because he didn't want to be there. He did not want a commercial partner, and he gave that signal in the best way he could. Why not? Because he'd also got a grant, and he didn't want the technology to go out the door. He wanted it to go out the door in 3 years' time, when the grant had come to the end. Meanwhile, of course, patent costs mounting up. So this is a failure on both our parts. I should never have had that meeting. I should have tried to understand where he was coming from in wanting to patent the technology, and he should have taken the time to listen to me to explain I didn't have an unlimited budget. There's no point not filing in multiple territories if you want to use the technology later. So that was a complete failure. Food matters. I was invited, in this case, I was representing a contract manufacturing company, and I was invited to give a talk to a West Coast biotech company. At that time, I think it was the largest biotech company in the world, considered themselves to be very, very important, very, I don't know if you've ever been there. They've got a double helix in the grounds where you can stroll along and have your academic, your discussions with your colleagues. I was invited to a lunchtime seminar, and then when I got there, I realised they were having the lunch and I was giving the seminar. So I was like the cabaret. And this happened some years ago, and I still remember it to this day, feeling very insulted. I'd gone all that way. And basically, they weren't really interested. I was just chatting while they were eating. And if mobile phones, well, I think they were, but anyway, some of them would have been on their phone and blah, blah. I was just noise in the background. And I felt that it was a complete disrespect towards me. I know contract manufacturers charge you for the work they do, but they also bring a lot of strengths, a lot of, in fact, patented technology often, a lot of know-how from other projects. And they're your partners, and they can often help you get to market, break down barriers that other people couldn't. So we didn't do any work with them. Okay, this is loosely based. No, it's actually, I've seen this more than once. You've got a commercial partner. Hooray, the tech transfer office has found one. And the agreement has got everything you want, upfront payments, diligence requirements, liability protection, and publication rights, which is what you need. The first meeting goes well. They're interested. In fact, they're really interested. They give you lunch. And they wear nice clothes. They're really interested in you, and it goes really well, and they talk and drag everything out of you. And later, though, maybe a year later, you realise that they've actually got an in-house project that addresses exactly the same thing. And what they're doing is comparing the two technologies, yours and theirs. They're not denying it. They've taken your technology on an exclusive basis in order for them to be able to compare the two. 3 years later, they give it back. That's how the agreement's set. you know, you've got the project back. But it's too late now. They've raced ahead. You can't find another partner. And often the reason why they've chosen theirs above yours could be very simple, very minor differences, or it could just be that they don't have to pay royalties if they develop theirs. But if you'd looked for a partner who had nothing in that space, then they wouldn't have done that. A quick one. Look at the product from all angles. It's another example with the regulators. I've got a new piece of technology, and it's just the same as the old stuff, except with different ways of analysing the data. Are there any risks you can think of? Well, I suppose the only risk I can think of is that the equipment might collapse. Is it heavy? Yes. Anyway, that happened. That's a true one. How many times a day will your drug have to be administered? I worked at SmithKline when we had Tagamet, which was the world's first H2 antagonist, ulcer drug. You have to take it 4 times a day. There was a little-known company whose name began with G, a little British company. We were a big New Jersey company. And they developed something similar. But that only had to be used once a day. And they took all the market because a patient really does not like a 4 times a day treatment. Don't forget the rest of your team. So put yourself into the shoes of your potential partners all the way along the line. Look at life from their point of view. Ask what they want. And beware of the false friends. Good luck.
Fantastic. Thank you, Susan. Very entertaining and informative, of course. So we'll take questions for both of the speakers in the last session at the end, if that's okay. So I'll now introduce our next speaker, which is Alberto Saini from University of Manchester Division of Pharmacy and Optometry now, like me, of recently. So I'll do a very brief bio. So Professor Saini did his PhD in polymer physics, did some postdoctoral experience in Japan before returning back to the University of Manchester in 2002 to take a position in polymers and peptides and establish the Polymers and Peptide Research Group at MIB. He works across a wide range of areas related to experimental polymer and biopolymer science, and in 2014 founded the University of Manchester spin-out Manchester Biogel. So, well.
Thank you. Thank you very much for the invitation, Alessandro. So yeah, so just to be sure, my background is in actually quantum physics. That's my degree. I did a master in that, and then I fell into polymer science because I chose the wrong project for my PhD, and then came to Manchester as a proper polymer composite person, shoes, plates, cars, and then got distracted by hydrogel and peptide, and then and saw the light in FBMH of all this biomedical application, and that's how I went. So I'm going to just tell you a bit the story we went through in terms of setting up our company and what we have done. So, which do I push here? Is it this one? Yeah. So just to say, first of all, I just want to describe a little bit how our group is set. So I'm a physicist, so actually what I'm interested is in this, which is mainly basically self-assembly of small molecules. I've done polymers, all sorts. When we arrived in Manchester, they gave us a peptide synthesizer. Nobody knew what to do with it. We looked in the literature, and these were systems that were very nice. So we do gels. I love gels. They're polystructural materials. Try to understand them is very challenging. But it turns out that actually they found some use, and as we were doing them, then suddenly people were starting to be interested in them, particularly for 3D cell culture. That's when people were starting to look at 3D cell culture instead of 2D to try to get proper environments, and then we started to work. Now, I tried to do some cell culture. It's awful, so whoever does it, well done, because I tried a little bit, and I said, no, I can't do that. So what we do now, we do the physical science in our lab, and everything else we do with other people. So I have more PhD in other people's lab than actually in my lab, but it means that I get the right supervision for cell culture, tissue engineering, and all sorts of things. So which means that through the years, we managed to develop a number of ideas for application and do quite a lot of work. And then finally, in 2014, we decided basically to commercialize our product. So this is more of a commercialization than a translation, but actually it also serves a translation purposes, as I will tell you after. So this is a little bit how we run our things at the moment. So we do science in-house, application outside, and then we have the company that can supply materials. So Basically, in terms of the technology, it's very simple. I'm not going to go into details. Most of it is published. We simply use small molecules and do these very nice hydrogels. So this is the one we use for cell culture. Here is one that we did with graphene because we are in Manchester. So we said we're going to stick it into it to get very good quality graphene. And actually, we use this for delivery of growth factors. So this is basically what we do, this kind of wonky gels. Now, in terms of when we went out, we have to actually then make it very simple for investors to understand what are we trying to achieve. And you have always to present them a problem. And for us, the clear problem, although that's not what we're targeting, we're just doing science. So the clear problem is matrigel and cell tracks, which are basically tumor-derived matrices that people tend to use. They're actually everywhere in the biomedical sector. They're a big problem, and actually there's more and more questions about them. Even journals start to question their use in terms of what people are doing with them because they're full of growth factors, of signals, nobody knows what's in there. But the main problem for the UK is that this is how you make them, and it's unethical. So you cannot make it in the UK. Manchester used to do their own. They can't do anymore, so you have to buy from outside. It's also not defined and completely tumorigenic. So the problem of not being made in the UK is that you rely then on US and Asia supply, and actually COVID created havoc. I think for matrigel at the moment, there's a 7 to 8 months lead when you order, so you can't get it. But it's actually endemic in the industry, everybody uses it. So you have companies that actually can't access it, or their customer can't access it. It's creating a huge problem for the biomedical sector in the UK. And of course, it's non-translational. Although people will use it for translational purposes, you can't use it in human. That's not allowed. So the solutions that we had is, OK, we're going to go for fully defined materials, completely synthetic. We know exactly what's in there. We can make it over and over again without any problem. Of course, in between these two, there's plenty of other materials. But matrigel is 40, 50 years old, and none has come close to it yet. So it is a big challenge. It is a big ask to try to do so. So you probably, from the start, we're not going to have a winner. But anyway, we tried, and we said we're going to do it and see where we go. So in terms of the commercialization, so first I have to disclose that I am director and shareholder of the company. This is the motivation that pushed us to actually go out. So one problem we had is that a lot of people were interested in our materials and wanted it, and the postdocs were starting to moan about making gels for other people all day long. And actually a German person, when I was in Germany, said, I will buy it off you. And I said, yeah, but the university is not very good at selling things. That's the last thing I want to do. The university is going to take me more time than the money I earn. So I said, OK, maybe there is a business. At the time also, somebody else would have done it if we wouldn't have done it ourselves. That include a company which came suddenly with a patent that was not what we were working for, but something else we're doing in the group. Weird situation. So we said, OK, if we don't do it ourselves, somebody else will do it for us. The other thing was for us to promote the wide use of materials. So one of the issues when you're a material scientist is that you know how to do it, and then you have to supply it to everybody. And the issue is that if the material is not available to the end users to buy, to get without your knowledge or without having to be interfered, then they won't use it, because then they will always rely on you. And somebody told me, if you get run over by a bus, I cannot get it anymore. So we thought having a steady supply of materials, also at the right degree, GMP, sterile, etc., that I can't guarantee in my lab, was a way to go for trying to get this spread around and people pick it up and use it. And it has been quite useful for that. Met the right person at the time, so that was Guillaume. So he's the entrepreneur. He spent a year without a salary. He left his kids in France, came, I think lived a summer in our house, drank all our wine, actually. We came back from holiday, there was nothing left. But anyway, he took the hit in terms of personal investment and basically set up the company beside us, and we supported it. So for me, it was also a good idea just to try something else, something different. I always liked applied science, going towards there. And the other one is financial gain. Of course, I am not on Zoom in the Caribbean, so therefore it didn't work. So this is really one you hope for, but never happens in this kind of situation. Very few people make any money. Actually, probably lost money. I cost money to my parents. They're moaning about it. So the question when we set up the company is, what do we sell? So now, in the area we work, I thought for us it was very important to have a formulated product. I didn't want to have a biologist to try to make these things. They are not straightforward to make. Therefore, we insisted that what we sell is something ready. They take and they use immediately. So there's no formulation, nothing to do, no awkward steps to do. Also, cells are very fussy, so every cell wants something different. So we had to have a family of product, and that has been quite a challenge to define which gel works the most, the best. You don't want to have an infinite number of products on your catalog. And then because academics are a pain, a design service, because they always want to add something, this function, these other things, etc. So okay, we can try to do a bit of that. Now, the challenge for us was to get out of the university, and unfortunately for us, actually the university had different ideas to us. When we went to them and said we want to do a company, they already had invested in somebody else. They had given them the patent we had made, so we couldn't access it anymore, so it was a big, big problem. We were lucky, we had access to a lawyer. He came, and then suddenly that calmed a little bit, the whole situation. We managed to negotiate our know-how, but unfortunately we had to give up the patent. That still costs us, because we have a company without a patent, we had one. And what is more painful is that I paid for that patent with my grant, so the university didn't pay for it, but still had to lose it. So they gave it to this other person moved to Nottingham, they gave the patent to Nottingham, and then they let it go, so it's now not sustained anymore. Anyway, we managed to go out with our know-how, and then we went to raise funds, and that's where I asked about UKRI, because once we are there, then you're like, where do we go? How do we get there? So Guillaume was very active, and for example, he went quite a number of times on the Isle of Man. There is every 6 months a conference for investors about life science. You can go and do your pitch. You can go as much as you want. Investors are there, and we found one there. The other thing, we found another investor, which is a local investor, which is Deep Bridge. That's just by talking to somebody on the train. That was, his wife was the tennis playing partner of my wife, and then we started to talk. So I go and see Deep Bridge. So these are basically what you call SEIS investors. Basically, people give money to Deep Bridge to invest. This is people with a lot of money, and basically they get tax break. So if after 3 years they get the investment going, they get their tax break. So that tax scheme incentive, but it means they have quite a lot of money to give this first tranche of funding for a company. So they were a good person to go to. And actually, it's interesting, you get very famous people invest in your company. I think we have one of the City football players which appears as our investors. It's quite good to say. So this is the story of the company. So we joined the university in 2002, and that's when we started to work on these materials. So the first grant really that made a difference for us was a EU grant, easiest grant ever. I think I wrote 3 lines, and I got 2 postdocs. And then we were funded by Solvay. It's a company that were interested in peptides, so they were quite interested. So these 2 grants allowed us to start the work, but this is the kind of timeline we are talking about. So first grant in 2004, which was £3,000 from the university, first paper in 2009, cell culture 13, and the first animal work in 2017. So it's over a decade of work trying to develop this type of systems. What really made a big difference for me was the EPSRC fellowship. So thank you, EPSRC. So I got an EPSRC fellowship for 5 years, which actually freed my time, because setting up a company took a lot of time. It gave me the freedom and the resources to actually really expand the technology. So then we found in 2014 Peptigel Design. That was the name for the company when we started, with the know-how we licensed out. And then we got the first tranche of funding from Deep Bridge. So then we set up shop at Alderley Park. AstraZeneca was leaving, so there was a lot of incentive to go there. And part of the funding round, we also did what we call friend and family round. So I went begging my brothers and my parents for money. So everybody chipped in, we put the pot in. Of course, everybody lost his money, so they were angry now. So, but anyway, so we all did that. So you go around, so you have a little bit of money to pay Guillaume for his coffees and his drinks and things like that. So, and then they came in and they gave us £125,000 at the time. So we managed to set up the shop there. And we actually launched our first product. So it's more of a commercialization than a clinical translation. So the first product came out in 2006, and we started to sell them. Of course, we thought everybody wanted them, and of course, nobody wanted them. So we had to think more and more, often and often, how we package this product and what the message is. Anyway, then we burned through our cash, of course, and then we went for the next funding round. And this is a bit the story of company. You go every year, every 2 years, try to get more money, and more money. So we managed to find Kiro from the Isle of Man. This very just wealthy person that decided to invest. And he gave us $750,000, basically, but unfortunately, it came with string attached. Deep Bridge gives you the money, you go and do your job. These ones were new in biotechnology, didn't understand half of it, and they were very interfering. So they fired our CEO. They forced us to change the logo because they liked this. So the reason for changing the logo originally was the color. So we ended up with a green logo again, so I don't understand what the person did. But anyway, it was very interfering, and it created a lot of issue. And what happened is that after they fired the CEO, they were doing a lot of mess, and then Aileen actually works in chemical engineering, which developed all this with me, had to go in and become a CEO. She went 1 year on a placement, And she was outsourced by the university on a secondment, but that was way too expensive because the university asked us to pay her salary plus 130% overheads, which really didn't work. So then she took some sabbatical. So then we got the funding, and then we launched these inks out in terms of trying to do new project, and then we started to have some clinical project going at the university. So all started to fit together. And these clinical projects were only possible because the company was supplying the materials sterile that you could use in animals. We couldn't have done it without it. And that's what the company has helped us to try to push toward these clinical translation and clinical projects. And then we got some more funding, again, Deep Breach, and this is funding from Cheshire. And they funded again another round, and then we managed to get some studentship to do further work in developing this technology. And finally, recently, we have started to collaborate with a company for actually clinical translation. So here we are looking to go into the clinic for an application in the eye. We have another application for endometriosis coming out. They're going to start in January. So the company has been very useful to provide these materials to push all these projects towards clinical translation as supported and prevented us to have to do that job. And then what's going to happen now? Well, you know, in a couple of weeks, there are a lot of things happening, but I'm not allowed yet to disclose anything. So the benefit of following this for us has been that we got quite a bit of funding through consultancy for our group. It has accelerated the materials development and also facilitated industrial engagement. The company don't want to have a relationship with a university for supply, so having a supplier that actually helped those kind of things. Co-funding and also collaboration with a wider community. Through the company, we access people in Japan, in the US. It's been quite interesting in terms of the uptake. The current challenges, you always to go and raise funds. So that's a cycle that always goes. Your interest and investor interest might not match, so that has been a bit of a challenge at some point. It requires your involvement a lot, so it is actually time-consuming when you do it. And also, for some reason, we are disqualified for quite a number of translational grants because we have also shareholding, so it's been a bit awkward. So we had sometimes to go outside to other universities to do stuff we could have done inside, just because there is a bit of a people are not sure how to deal with conflict of interest, so it's a bit of a thing. But the main difficulties has been for us after the fire the CEO we had is to find somebody to take on the company, and that I think is a problem for a lot of companies. There is not enough people that are just professional CEO that can do that job and help academics through. As academics, we shouldn't have gone into that ourselves, but that has been a big, big challenge to find the right people to do that. Now, this is the final slide that I pinched from Erin. She was really good at this kind of motivational speech and things like that. For me, the main learning thing is that if I had to redo it again, I would have to make sure we have somebody in the company that can actually run it, because for us, it has been a big, big challenge while we were trying to get our careers, family ongoing, and on top of it, having to take care of the company. So I think there is a model I liked a lot, because I think some Dutch people talked to me in Holland, where they have actually professional CEO that they de-risk, so half of their salary paid, and they go into university and they say, I'll take your company on, you help me, I'll do the CEO job, I'll get all this off, and then I'll sell off the company. And that works quite well. I think there is a bit of a gap there in terms of who can run these companies and trying to find quality people, especially in the Northwest. We had a lot of candidates from South, but they won't come north to just run a small company. So I think the Northwest is one of the biggest challenges we have found. And thank you for, sorry, Bill, 1 minute over.
That's it. So does anyone have any questions for Alberto or Susan? Can we have the mic? Oh, it's on. Fantastic. And no feedback. So a quick question from me. I don't think anyone's got hands up. Did you ever apply for any Innovate funding once you had?
We, as a company, we didn't. We have applied with Nano Optima. So actually, the Innovate funding has grown quite a bit recently, and a lot of small companies are applying on it. So we have some grants now in the pipeline, but we had enough funding to run really the company at that stage. So we didn't really. And also, the beginning of the work was really to try to understand what kind of product we were going to sell and how. So we thought we could gel on the market and people would buy by slightly different. So academics will buy, and for example, academics will do the work that they like, do the research, they will develop the materials. But if we go to a CRO, unless we tell them this is a replacement, this is the protocol, you can use it in your workflow, they won't touch it. So that's where then the Innovate UK grants start to come in. So we are working with some CRO to develop protocols for them, or even for their customers, to replace material, but you have to give them the protocol, which means you have to get some of that funding to do the work yourself.
Thank you. Anyone else have any Questions?
You said that you did it because you had to, otherwise someone else would have done it. Would you do it again?
Yes, but in a slightly different. Once you know the mistakes in a slightly different way, probably a bit more prepared. With Eileen, we are quite. How do you say? We don't think much about buying. We buy a house in a weekend or things like that. So it's just said, let's do it, and we went out and we started to do it. But I think we were not really prepared on the other side. Guillaume came over. It was a bit all shambles and things like that. So I think having a bit of more of a plan, I think that would have worked a bit better. So, but it's. With DeepBridge, we're keen on giving the money, so you get the money, then suddenly you're like, and then you discover the product is just not right. There's been quite a number of evolutions. So it's a bit that cycle. We have reinvented our product and our catalog over and over again. But I would do it because what it has done, whether it fails or not, it has actually allowed a lot of people to use these materials to really get them there. And when people buy for them, you get feedback very quickly. So, so it has been quite useful for us to improve. So, and actually, some of the newest formulations seem to work actually very well. So we have improved product, improved formulation that we use. So I think he has been, as a complement to our research work, very useful in terms of push the materials outside. I think one of the issues is, especially the clinical side, the companies in that space, they won't have a chemist to do these things. So either you give it to them and then can use it, you can have a supply for them. If not, you have to do everything from design of the materials, the synthesis, all the way to the clinical translation, and that takes just too long for us.
More question.
Thank you. It seemed like you had a lot of kind of lucky or unlucky things along the way. Like if you'd been following a clear theoretical pathway, you wouldn't. That it just didn't match up at all to what actually happened. And I just wondered whether you had some kind of more realistic mentorship or engagement from people who'd made those mistakes before, and how can we kind of capitalize on mentorship, and it's for Susan as well.
Yeah, so I think when I asked now for the advice, and I was at the UKRMP meeting the other week, and for me the key thing, and Aileen went on it, I didn't, it was the accelerator programs, the ICURE. Those were key because that's only when Aileen went through that we understand what proposition value is and actually how to present things to investors and things like that. So I think those accelerators have been very, very good. I've seen quite a number of people. And at Alderley Park, there is one in particular on oncology. And a lot of companies have come out from there. But it's more than mentorship. It's a proper training program on how to talk to investors, how to set your proposition value. And then when you come out, the good thing with those is that there are investors on the other side that wait for your pitch. So, and a lot of companies in Alderley Park have come out that way, like AstraZeneca and things like that. So I think those accelerators have been very good. But when we started, there was nothing of the sort. So we were a bit on the street. And a lot of luck, a lot of meeting people in the pubs where we live. And that's where we met the first person who helped us to raise funds. So it's a bit of a bizarre, but it's always like that usually. So you just go randomly. And then he ends up somewhere. We knew where he wanted to go roughly. But I think I would advise anybody who wants to do this now is to go through an accelerator program. Thank you.
Thank you very much, Alberto. So just a couple of quick things. Let's thank all of our speakers again this afternoon.